Hello and welcome back to Arduino for Amateurs. This is episode number 13, Infrared Transmission. As always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the Bidhaven Hackerspace. And what I'm talking about today is the next step after our last couple of videos. So in the two previous videos, we talked about infrared remotes, infrared data transmission, how it works, and how we can turn our Arduino into an infrared receiver. In this video, we're going to talk about how we turn it into an infrared transmitter. That is, how can we programmatically generate infrared signals to control other devices in our environment. So this board is the infrared transmitter I'm going to be working with. As you can see, it's very similar to the infrared receiver. It's got 3 pins on it. Right now I've got those 3 pins plugged into my breadboard. One of them is wired to ground, one is wired to power, and one is wired to data. And we'll see what exactly that wiring looks like in a moment. At the top here, you see this clear LED. That's actually an infrared LED. So that's the emitter that's going to be generating the pulses of infrared light that we'll be using to control other devices. Not all infrared LEDs come on little boards like this. And this one's about the same size as the infrared receiver boards, maybe a 1/2 inch or 3/4 of an inch on a side. Sometimes these are just plain LEDs, and then they'll just have an anode and a cathode like a normal LED, and you'll wire them up the same way. In this case, I bought a package on Amazon of transmitters and receivers that all came in this board form factor, so that's what I'm using. One other thing I wanted to mention just on the wiring front, I don't think we've used these in any of the previous videos, but the jumper wires, the DuPont wires that we're using, the ones that we've been using for most of these exercises have been male to male, right? They've got the metal prongs on either end, and you plug them into 2 tie points on your solenoid breadboard in order to make a connection. However, there are also male to female DuPont wires available, like these ones, where it's got the metal prong on one end and then a socket on the other. Why am I pointing this out in this video? Well, as we mentioned in the last ones, infrared is a point-to-point protocol. You need to physically point the transmitter at the receiver in order for the signal to be reliably conveyed. Sometimes, if you've got an LED like this one that's on a board and it's plugged directly into a breadboard, it may not be at quite the right angle or quite the right orientation to reach the receiver that you're trying to program. So just keep in mind that you can use wires like this rather than plugging your transceiver board, like this guy, directly into the breadboard. You can plug those pins into the receptacles on the end of this DuPont wire, plug these into the breadboard or into the Arduino, and then you can orient the transmitter however you need to line it up with the receiver you're trying to program. So just something I wanted to mention. I'm not actually going to use this in the video because I've got a device here with a receiver that I can put right next to the transmitter. But if you're doing this over a distance, like if you're trying to control an air conditioning unit or a space heater or audio-visual equipment or something else that has an IR remote that you want to simulate, you may need to orient the transmitter accordingly. So this is the board that I'm going to be working with in this video. As always, up here we've got our actual Arduino. Down here we've got an IR receiver, and this is the one that we've used in the last couple of videos. This is that black sort of dome receiver. And we have our IR transmitter. This is the one I just showed you a couple slides back. They're both plugged into the breadboard. They both have 3 prongs, power, ground, and data. As you can see here, the receiver has a black ground wire and a red power wire going back to the appropriate rails here. And then this green wire is data. That's going back here to pin number 7. So digital input 7 on our Arduino. The receiver similarly has power and ground. Those are connected to the appropriate pins here. And then this blue wire is connected to digital output 3. The reason it's connected to digital output 3 is the IR remote library, at least version 2.6, which is the version that I'm using for this demo, hardwires IR transmission to output number 3. Now it uses pulse width modulation, like we talked about a couple videos back, for simulating analog signal creation. So if you want to, you can go in and manually manipulate the library files to put it on a different PWN pin. But what we're going to do is we're just going to go with the default. We've got it plugged into pin 3, which, as you can see here, has the little tilde on it, indicating that it can produce a pulse width modulated signal, which is what it needs to do for this transmitter. Okay, so that's what we've got. We've got our receiver plugged into pin 7. We've got our transmitter plugged into pin 3. Let's see what we do on the software side of things. So I'm going to flip over to my Arduino IDE here. And you probably remember this from a couple videos back. So this is the simple remote program. I've got this loaded into my Arduino right now. And this remote that I'm holding up here, this is the remote for the LED light strip that I've got in my room, in my home office here. I've also got another one of them right here that I'm going to be showing off for the testing. But what this allows us to do is, see, I can change the color in my office. Change it to blue, change it to green, change it to red, change it back to white. If I want to, I can also point this at my IR receiver and see what hex codes are being produced by this particular remote. So if I hit red, I see it's FF1AE5, and it's being encoded using the NEC standard. Again, that's what this switch statement is. It tells me what standard the remote is using. If I do green, I get that hex code. If I do blue, I get that hex code, etc. So this remote is producing signals corresponding to those hex codes. It's producing an encoded digital binary signal, but when we express it in hex, these are the codes that we get, encoded using the NEC standard. What we want to do is simulate the signals that are produced by this remote using code, using that IR transmitter that I've got plugged into my breadboard. So let me flip over to that program. And this is a very, very simple program designed to show off how the infrared transmission works. So you see here, I'm including the IR remote library. It's the same library that we use for receiving infrared signals. We're using it for transmitting them. I create an object called sender of type IR send. As you might know, that means I'm going to have this sender object to interact with during the program. Setup, nothing in setup. As I said, the sender library is hard-coded to use pin 3 on an Arduino. So the only thing that I would need to set up normally is to say which pin it's on, and it already knows, so I can skip that part. And then we go into our loop. So we have two data structures here. One is an unsigned 32-bit integer called data, and that is FF1AE5. If that sounds familiar, that is the code for red on our remote control. Okay. And then we have an unsigned 8-bit integer called len for length. That's what is the length of the data packet that we're sending with our IR transmitter. For an NEC remote signal, it needs to be 32, so that's just set to 32. And then we call the function send NEC. That means send the data using the NEC protocol, the NEC format, data comma len. So we're sending FF1AE5 comma 32. That's all we're doing. So we're sending the code for red. It's 32 bits long. Then we delay for 2000 milliseconds. So we delay for 2 seconds. We change the value of data to FFA25D, which is the code for blue. Then we send that and we wait for 2 seconds. So again, this is a very simple program. All it's going to do is send the code for red, wait 2 seconds, send the code for blue, wait 2 seconds, then go back to the top of the loop. Send the code for red, wait 2 seconds, etc. Now, what am I going to be receiving this with? Right here, let me make sure I'm on the camera, I have a light strip, which is still on the spool, so I'm not going to leave it plugged in for too long because it'll overheat and burn out. but this is a light strip that's the same as the one that's on my ceiling. This little controller box here has 2 sockets that plug into the light strips, and then this little guy here is an infrared receiver. So if I plug this in, I've got a power supply on my desk here, you'll see it's set to red. And then if I hit it with my remote control here, say I want to change to green, or blue, right? Now I'll put the remote down, I'll change it to white so you can see the contrast, and I will upload this program and let it start running. So I upload the program, point my IR receiver down here at my emitter, and you'll see it's changing from red to blue, red, blue, red, blue, right? I know, not the most exciting demo, but the basic fact is we've read the remote control, figured out what the codes are, and now we are simulating them using the Arduino. You can do this with any device that connects to an infrared remote control. If you have a space heater, if you have a lamp, if you have light strips like this, anything that can be controlled via infrared signals, you can write a program to do that with your Arduino. Now, another thing that you can do, and the other program that I'm going to show you in this video, is you can receive a code and then send out another code. So let me switch over here. This is our IR translator. Now, before we get into that, let me show you. We'll go back to simple remote here. I'll clear this up. I'll upload this back into my Arduino. Another device that I want to show you. So this is another simple infrared remote. This actually came with my Arduino kit with the Elegoo super simple special kit or whatever it was called that I got from Amazon. It had a bunch of bits and pieces in it. And this is not designed to do anything light related. So if I point this at my lights and I hit 7, 8, 9, which are the buttons I'm going to use for this demo in a minute, see nothing happens, right? If I point them at my receiver here, I hit 7, 8, 9, I get new hex codes. I get FF42BD, I get FF4AB5, I get FF52AD. So that's what I get for hitting 7, 8, and 9 on the number pad on this little remote. So despite the fact that this little remote is not designed for controlling this light strip, I can programmatically bridge the signals that this is producing with the signals that my light strip is expecting. Let me show you how. Switch back to this translator program. So I start by including the IR remote library, because obviously that is the library that has the functionality I need for both receiving and sending infrared signals. And then I kind of mash up the 2 programs that we've already seen. I create a sender, right, of type IR send. I do all this stuff to instantiate the receiver. So I declare the receiving pin is number 7. I create a receiver object. I use this decode results data type to decode the results coming in. I have the key value equal to 0. I have my data and len from the transmitter demo. Then void setup. I turn on my serial monitor because we're going to use the serial monitor in this. Let me open that window up here. I turn on receiving for my receiver. I turn on blink 13 so that the LED on my Arduino will blink when it receives an IR signal. Okay. And then this is kind of out of order, but the first thing I do is if key value is not equal to 0, so if a key value has been received, then I am going to send using the NEC format to data, len, right? So I'm going to send the contents of data encoded as an NEC signal out of my transmitter. That's what the sender here is. I'm going to print to my serial monitor, send data value, and then the data value I just sent in hex. And then I set key value equals to 0, and then I turn the IR receiver back on. This took me a little while to figure out, so I just want to emphasize this. The way the IR library is set up, and again, I'm using IR Remote version 2.6. This may be addressed in newer versions. I'm not sure. I didn't dig into that. There are significantly newer revisions of this, so this problem may have been fixed. But at least in the version that I've been playing around with, the library can either send or can receive. It can't do both simultaneously. So that means that you need to re-enable receiving after you're done sending. So after it sends data using the NEC format, prints it to the serial monitor, turns receiving back on. Then here I have my my receiver routine. So if there are results, if the result value equals all Fs, remember that's the I held the button down too long code, set the results value to key value. To the monitor, I'm going to print the results value. So when it receives an IR transmission, it's going to print the results to the serial monitor. Then it will set the data according to what it receives. So if it receives 7, it will set data equal to the hex code for red. If it receives 8, it will set it equal to green. If it receives 9, it will set it equal to blue. So what's happening here is I am receiving an IR signal. I am matching it up with what I want that button to do, even though it's not the remote that's supposed to control this thing. I am changing the value of data to that value. I am delaying for a second, going back to the top of the loop, and then since the key value has now been set, right? Key value is results value. I am going in here and I am sending that data out. Okay? So it receives the data from my remote. It figures out what code it should send, depending on which button I pushed, and then it sends that code out. So let me plug my little receiver demo device back in here. You see it lights up. All right, so it's lighting up blue. I'll send this to our Arduino. And then what should happen is when I push 7, which again, this is not the remote that's supposed to go with this case, but it should change this to red for me. Oh, red. Sorry, I had to get it closer to the transmitter. Green, red, blue, right? I'm sorry, it's kind of hard to hold all this stuff at once, but once the receiver gets close enough to the transmitter, then it works pretty well. So there we go. So we're able to get the results and then send the appropriate data. Get the results, send the appropriate data. Get the results, send the appropriate data, right? So we're able to use this as an IR translator, right? We can receive the signal from whatever remote we want, turn it into the signal that we want, send it along. If we want to have multiple devices controlled by a single remote, we can do that. We can wire up these IR transmitters in series so that it broadcasts all of them at once. And we can say, okay, when I hit this button on my remote, I want the light strip to turn on. I want it to change to this color. I want my space heater to turn on. And I want my television to turn on, right? Whatever you have that is a line of sight from your Arduino, you can point a transmitter at it and write a program to turn it on. Pretty neat. Obviously, this is more helpful if you can connect it to other inputs telling you when to turn things on, what to do. So we'll talk about that some more in future videos. But in the meantime, thanks so much for your time. I hope this was useful.